talks they can get into. Some customers lower out, they have to pay royalties.
Well, it looks like most everyone's here, so I'm going to go ahead and get started. Welcome to IoT Deep Dive number 10. If you haven't already, please connect to the Wi-Fi on your laptop. We're going to be using the K64F board, which is the little blue board up here in the front. So if you need a board, Ethernet cable, or USB cable, please grab them and get them all hooked up. You're going to plug the board in your computer over USB and then into the Ethernet jack that'll take you to the internet. So today, we're going to be talking about a little thing called mbed client. We're going to be using it with a thing called mbed connector. Mbed client runs on your embedded device on the endpoint. Mbed connector runs in the cloud. I'm going to show you how to shove data up to the cloud and get stuff back from the cloud. This time around, we're talking about the story of embedded device to cloud, and next time we're going to talk about web app to cloud. And so at the end of this meetup and next meetup, it's going to flow so you can go the full IoT stack. To do this, we're going to talk about the data models involved, specifically lightweight M2M, because that's the nitty-gritty of how we're going to enable IoT on these endpoints. We're going to talk about the new IDE that we're going to be using to enable this. We're going to go over some code examples, and finally we're going to go over the web API console, which lives on connector.mbed.com and shows you all the data that comes in and out. So, without further ado, for those of you who are familiar with web apps, you probably know about HTTP REST and how you've got get, put, post, and delete calls. Well, in the embedded space, we decided to use the same paradigm since everyone's already familiar with it. And so you've got HTTP REST calls on the web app to cloud side. And then on the embedded side to cloud side, you also have what will look like REST calls. But they're not over HTTP anymore. They're over another protocol called CoAP. But just like you could get resources and put resources on the website, you can now treat an endpoint the same way. So if I wanted to read a sensor on a device, from the website it'd say, hey, get me that sensor value. It'd go through connector would say, all right, 1 second, goes, grabs it, and hands it back to you. Likewise, you could then put something to the device to change the value on it. So you'd put something to connector over REST, and it would then put something to the device over CoAP. Similar for posting and deleting. So it's all the same keywords, all the same stuff, just the implementation gets tweaked slightly. Any questions? Cool. And just to emphasize, we're going to be focusing, that really doesn't show up well, does it? We're going to be focusing on this part of the story today and this part of the story next time. So there's two hierarchies we're going to talk about. One is actually we'll just skip straight into it. Every user is going to have a domain. The domain is a little universe that all your devices are going to live in. Each device is called an endpoint. So that K64F, that little blue board, we're going to consider that the device endpoint. They all exist. I can have multiple K64Fs, so all of them hook up under my personal domain. So I can have endpoint 1 and endpoint 2 and endpoint 3 all in my domain. And then every endpoint can have multiple resources. So it can have an LED that is writable and readable, a temperature sensor that is readable only, and a digital output that is readable, writable.
Austin, do we assign the unique ID on each endpoint, or is that already embedded, or how
We
does
will
that?
get to that in about 10 slides.
Sorry.
So this is what the data model looks like. Every domain has multiple endpoints, or a single endpoint as you choose. Every endpoint can have multiple resources. The domain handles authentication, so it verifies that the endpoints are part of your domain. Really what's happening behind the scenes is every endpoint hits the cloud and goes, hey, I'm registered to this guy's area, here's my stuff, and then embed goes, or connector goes, yeah, that sounds about right, you get lumped over here. And so that's how we prevent crosstalk between different domains. It's just handled at that level. Each endpoint, again, is a device, so it's not necessary that it be a physical board, but for ease of explanation and understanding, I'm just going to say that K64F board in front of you, that little blue thing, that's your endpoint. It's a device. And then every endpoint will have multiple resources. We access these, yeah?
Do all endpoints have to go through the domain?
Yes. So the entire thing is predicated on the embedded devices going to the connector cloud and the connector cloud going to your web app. And it's done that way because we got into this a couple meetups back, but essentially HTTP stacks and TCP stacks are really, really heavy, and it's really hard to do security properly. And so we're going to use the embed client on the embedded side and connector on the web side. And because we've made fancy schmancy stacks, you don't have to worry about the security, it just works. And so from the developer perspective, it becomes, hey, shove this thing over there, and you don't have to worry about it getting there, you don't have to worry about it being secure, it's just all taken care of. Whereas if we were to go directly from web app to endpoint without a middleman, without a broker, it would have to talk straight to it. Whereas in this case, we're actually using two very separate protocols. Going to point out at this point that everything is accessed via URI strings. So if I wanted to read the resource off of that endpoint, I would say /endpoints/endpoint name /resource that I want to read. And that's how I would get the value from that temperature sensor or that LED. Breaking down the model, it winds up looking like this. Every resource is not just a value. It actually has a little bit further of organization. The extra bit of organization that we put on top of it is part of a spec called OMA Lightweight M2M. If you're not familiar, OMA is what all the cell phone carriers have used for the last 25 years. It's how they provision firmware updates to your phone. It's what SMS runs on top of. These guys have a very long history of doing machine-to-machine and distributed management. And so we looked at it and we said, yeah, you know, you kind of know what you're doing. We're gonna follow your standard in this case and use that. So it may seem a little bit weird, but hopefully I'll explain it well enough that you'll get the gist of it. Really, the reason that we're using lightweight MDM is it is a standard, it is widely accepted, and we believe in using standards because if you don't use a standard, no one else can talk to your stuff. So at the end of the day, if I want interoperability and I want someone else's web app to be able to use my endpoint, you know, assuming I grant them security access, they have to be able to understand it. And without a standard, they can't. So that's what we're doing. Each resource breaks up into 3 levels. There's an object ID, an object instance, and a resource ID. And I'm going to drill these 3 things into you over and over and over again for the next 2 hours because they're very, very important to how you find things. To that end, let's take an example. We could have a temperature sensor object. That temperature sensor could have multiple resources. Let's say it has a max value, a min value, and a sensor value, are the 3 things it has. The way that those would get represented would look like that. So the object ID would be the same, because all of them are part of the temp, or the temperature object. All of them are part of the first object instance, and since we're electrical engineers, we start counting from 0. And then each resource ID is separate for those 3 things. So the temperature object ID, this bit right here, is 3303. First instance, so 0. And then max value, its unique identifier is 5602. Min value's unique identifier is 5601. And sensor value identifier is 5700. Any questions at this point, other than where I got these magic numbers from?
So object IDs are predetermined and they're not just made up. There's probably some header file or something that maps like names to numbers.
So we'll get to that in just a second. There is, because it is a standard, the OMA LWM Twin subcommittee on IEEE something or other essentially has this giant list of predefined things. And much like with BLE, they decide to say, here's a list of stuff, we're going to give this to you, and then if you want to do something custom, here are the number of ranges that you can use to do that. So I chose well-defined ones that are defined by spec to demonstrate this example, but I could also either use my own custom numbers, in which case interoperability goes out the window, or the better way to do it, because it is an open spec document, you can create your own object IDs and your own resource IDs and submit them to OMA for officialization. So, and it's actually pretty easy to do that. All you need is someone to sit on the committee and dedicate about 6 months of their time to push it through. So you'll see when we get to it, like the IPSO committee, they've pushed through like 20-something object IDs and 100 or so resource IDs because they've got the people to sit on the committees. So we will get to that webpage, I think, in 2 or 3 slides. I'll show you where all these magical numbers come from. I believe he had a question next. Sir in the Seattle t-shirt? Question? Nope. Okay, sorry.
So it seems like the 2 first ones are time sensitive, where that's going to depend on the code. You're actually tracking data and then identifying a max point.
So they're not time sensitive. Well, The protocol itself, LightWave doesn't care about the time, it just cares that there's a resource.
Okay.
And what the resource value, what it means, is what we're defining with these three numbers.
So you have a definition and you implement that in your code, essentially.
So all of these are defined by the spec. And so I just said arbitrarily, for example, I have a temperature sensor and I want to know what the most recent maximum value, the most recent minimum value, and then the actual current sensor value are. So I would assume that your endpoint is over time comparing each time it reads a sensor value against the min and max. And if it's greater than the last max, it replaces it. And if it's less than the last min, it replaces that and it keeps it.
Okay.
But that's entirely up to your endpoint code to decide what to do with. Savvy? Yeah.
Okay, that actually does raise a question.
Yeah.
So does the resource ID, does that refer to a specific value, or is it just an ID for like some lookup somewhere else that specifies the value elsewhere?
So the combination of the object ID, object instance, and resource ID together address a single value.
Okay.
So I use these three things to navigate to what I want to see. Because this temperature sensor thing could have, this temperature object could actually have multiple sensor values. Because let's say I've got one of these super fancy IR temperature things that has 7 sensors on it. They make these, by the way. I think one, I tore something down that actually had 3 different temperature sensors on the die itself, and it did a moving average of the 3 sensors. And so in that example, there would be a single object, one temperature sensor object ID, one instance, and then there would be 3 different sensor values. And so what I could do there is I could either give them my own custom resource ID, or the better way to do it would be have a single object ID, multiple object instances, each having the same resource ID. So if I had a temperature sensor that had 3 things on it, I'd do like 3303/0/1 and /2, and then put 5700. And so if I wanted to get, the first die, I would say /0. If I wanted to get the second one, /1, the third one, /2. Does that make sense?
I think so. So each sensor value needs its own specific instance.
Yes. Every value, if you want to read a different value, it needs its own unique path to get to it.
Okay.
So the 5700 is standards defined as well, not just the object codes? That is, each resource ID is defined by a standards body, or is that my?
We'll get to that in just a second, but there's essentially a range. Off the top of my head, I want to say 0 to 1024 that are locked in by the standards body for object IDs.
Like ports.
And then there's like a reserve section, and then there's like this 4,000 or 5,000 section where it's like, whatever, define it as you please. That's a similar thing for resource ID, although I think resource ID, the non-spec defined one, starts at 4,000 something. And so in this instance, the resource ID that we're using, 5700, that was defined by the IPSO conglomerate, not by OMA. And so it doesn't get one of the early ones, it gets one of the later ones, but it's still part of spec. So whoever's server winds up reading this can look at it and say, oh, 3303 is a temperature thing, and 5700 is a sensor value. Cool, I understand that.
But there are unallocated ranges as well for the resource IDs if I want to do custom implementation?
Yes, and there's a whole official process for getting your resource and object IDs added to the spec if you like. Yeah. So now that we've talked about the spec, I'm going to show you the spec. Forewarning, the spec is not kid-friendly. It is not cute and cuddly. This is it's written by a bunch of engineers who are very, very engineering. So I'm going to walk you through how to use it, and hopefully in time it'll get more pretty. So I'm going to go ahead and open that. Can you guys see this all right? Good. So if we scroll down the page, we very quickly hit this object ID class area. So now we're going to be looking at the object IDs. If you notice, the ranges are predefined. So OMA specific ones are in the range of 0 to 1023. So these are reserved by the governing body. There's then a buffer section from 1024 to 2047. There's external labels and X labels. So those resource IDs, or those object IDs we were just using, were in this range, correct? That means they are not OMA object IDs. They were defined by a third-party body. In this case, the IPSO organization, who are for the standardization of sensor objects. So if we scroll down, we reach the first section. These are all OMA specific object IDs, and most of these are geared towards device management versus device data. So all of these things are things around like your device information, security info, access control, connectivity monitoring, firmware updates, location data, so telemetry, and all kinds of good stuff. I'm going to point out number 3, which is the device information. So I'm going to load that up a little bit. So number 3 here on the list is called the device object ID. I'm pointing this out because the code example we're going to have here in a bit will have this object ID. So I want to show you what its magical resource IDs mean. If you notice, the resource IDs are nowhere near it. It's actually hidden behind this wonderful little raw XML document right here. So we get to open it up and sift through a couple thousand lines of XML data to figure out what resource ID means what. We're working with them to try and give them a better GUI so you can have like a nice visual thing that says, oh, 0 is this, 1 is this, but all in due time. So if we click and open the XML file, we get wonderful, wonderful XML, which I'm scrolling down to where the XML actually starts. And what I'm going to decode for you here is object ID of 3 is for the device. So we're going to scroll down. And now we've got item 0. This is for manufacturer. Item 1, this is for model number. So what did I say that was? 0 is manufacturer? One is, someone help me out? Model number. I'm going to scroll down a little bit. All right, what is 2?
Serial number, 3 firmware version.
Cool. And so on and so on and so on. If we scroll down to the bottom of the document, we'll see there's about 16 different resource IDs in this object. So if I wanted to get the manufacturer ID number from this device, I would ask for /3/0/0. See where this is going? Object ID, resource ID. This is just the first instance of it.
What do you put in front of that? Like a get?
Yeah, so we'll get to that in a bit. I'm just making sure that we understand the path to the value.
Okay.
And then if you were to ask for this, by the way, you would then get a string that would say like, my company name of awesomeness or something like that.
I'm assuming that instance IDs are 0 based and they just increment
Yes.
by 1.
They do not have to, but if you use, so there's no part of the actual spec says they have to increment by 1 each time. They can be anything you want. Good practice indicates you start at 0 and increment by 1. Unless you explicitly try and set it to something other than that, the default behavior of the library will increment by 1 each time.
Is that something that's assigned by somebody, or is that something that is hard-coded? So if I throw in a device, if I have a network of 10 devices, and I throw in a device, do I have to know that I have 10 in mine and this is the 11th and nobody has 11 reserved?
Nope.
Because it's specific to each endpoint. So each endpoint will have, they all have their own temperature sensors associated with each endpoint.
Okay.
So it just, if you were to add a temperature sensor to each endpoint.
Okay, so it's by the endpoint.
It's right, yeah, exactly. So keep in mind, it goes through your domain, then through your endpoint, then through.
Got it. Okay.
This thing really only ever gets incremented in the case that you have multiple of that type of object on that device.
Right.
So if I had multiple temperature sensors plugged into that board, which I could plug I think up to like 10 or 15 in there if I really wanted, then you'd start seeing this go up, assuming I use the same object ID, which would be good practice. And I'm going to point out at this point, this is entirely overly flexible and overkill for most daily uses. The spec was designed to handle everything between you doing 5 things and a thought experiment and a corporate company doing 10 million devices and having to have a server program automatically manage them all. So it's not terribly friendly for people to read, it's more built for machines to interpret. Good? Cool. So that's that. Going to go back one page real quick and keep scrolling down. So these were the object IDs. If I scroll down, I will get out of the OMA official ones, which ends at 15. And then I get into the unofficial, or the official non-OMA ones.
So is there any like a throttle limit, anything like that, with the data we post?
We will get to that in a bit. When we get to the actual code example, I'll talk about that if that's okay. So if we scroll down further to the page, we can see that there's some other really cool object IDs that kick in. I'm looking for the one that I actually just used. So we've got some digital outputs, we've got some digital inputs, analog in, analog out, generic sensor, luminosity sensor, presence sensor. Oh, and lo and behold, here's our little old friend 3303 that I was using earlier. So this is where I got that from. There's some humidity sensor, power measurement. And I'm going to jump down the page quite a bit and now come to resource IDs. Resource IDs have similar rules regarding their numbers, and they are defined right here. 0 to 2047, so 248 or 2048 unique IDs are reserved for OMA, and then after that you get other ones. We scroll down, we'll see a couple of them. What was I using earlier? Doing 5700, right?
Yeah.
It's like here's min range, max measured value. There's a whole bunch of them. There we go, 5700, sensor value. This is where I got that number from. Any questions?
That would get overloaded a lot.
They're designed like that right now. It's designed to be incredibly flexible. And so the idea is if you want to prototype something, use the existing ones and kind of figure it out. I should mention there's other data that gets sent along with these. There is metadata tagging. So you can specify the type of the resource, the type of the endpoint. You can specify all kinds of other metadata bits aside from these. So this is just a starting point that you can go for, and then you can add other stuff on top of it. Cool? Okay. We're getting there, I promise. So here's another example. Let us create a temperature and humidity sensor. Let us figure out what the paths would be for those, yeah? So I'm going to give you this information. I would like y'all to take 2 or 3 minutes and figure out really quick what it would look like, assuming there's only one sensor per endpoint, what the paths would look like. How would I read the temperature sensor value? How would I read the humidity sensor value? What would the main path look like?
I can help too, I'm Brian. Hi.
Oh, right, my colleague Brian is here. Incredibly knowledgeable. Okay. So if I were to ask for a temperature sensor value and a humidity sensor value, they would look like this. So I would try and read that address path. Everyone good on that? Cool. Here are some of the more common object IDs and resource IDs. These are the ones that I use the most on a daily basis to just rapidly get stuff out and testing and showing it off. Again, I gave you the slides earlier. You know where the spec document is, so good to go. Just keep in mind that the object IDs that are, under 1,000, they're special. They're very, very powerful and are used for data management more than data transfer. So things generally above 4,000 or above 2,000 are used for what I like to think of as the data area, whereas under that is used for management. So like the device ID stuff, if I was looking at an object ID of 3, so /3/whatever, I'm going to get manufacturer name, serial number, firmware data, usually stuff that tells me what is running on that device, when it was produced, who owns it, things like that. The firmware update object, which is like object number 5 or 6, That's not about transferring data, that's about managing my device and making sure it has the latest and greatest in security on it and things like that. And then when I get up above 2000, I start seeing stuff like, oh, how do I toggle the input outputs, or how do I read data from the device? So two very different areas to think about there. Takeaway, just gonna emphasize this one more time. There's the object ID, object instance, resource ID, sorry, object ID, object instance, resource ID. The path describes how to get to the data. So it's nothing more than really just a way to access it. And it's built so that you can have multiple instances and multiple different things all coexisting. So to get a single value, I have to specify all three of those things. Other very important thing that messed me up for a while. The resource IDs can get reused. So if I was using below 2000, those are reserved for a reason. And it's because an object ID can reuse them. So for example, /3/0/0 and /4/0/0, these mean totally different things. This resource ID in this context does not have to mean the same thing as this one. And it's because each of those object IDs redefine what the resource IDs do when less than 2048. When you get above that, the 5700 all of a sudden is reusable between them. Cool? So that's why I made sure to show you diving into that resource ID of 3, or the object ID of 3, what its resources meant. Because if you then look at 4, they mean different things. And that's because they define those objects to have specific resource IDs with specific meanings. Savvy? Savvy. Other thing to note, the resources, the values you're pulling can be of one of two types, changeable or non-changeable, static or dynamic. Static resources are exactly what they sound like. Once they're set, they don't change. The device actually locks them in place and it's like, nope, you can't change this. Dynamic IDs can be updated either locally or remotely, as you see fit. So things like manufacturer name, MAC address, different things like that, those tend to be static objects. Things in the management plane tend to be static objects. They don't tend to change unless you update the firmware, in which case it kind of revs everything anyways because the firmware is where those static things are stored. Dynamic objects, on the other hand, are things like arrays, sensor value readings, things like that can be changed over time either by reading the sensor or by the server saying, hey, you're now going to turn your LED purple instead of red. Right, so now we're going to take a look at the new IDE to do all this fancy shenanigans. Because for those of you who have been coming back for the last couple months, which is about half the room, remember Yada? Remember that experience? We are now using that to build embed client, and we're now using that to do all of the really cool stuff. There will eventually be a backport that'll work in the old embed 2 environment, but for the moment, the Yada environment going forward is the way to do it. To do that, we did some awesome shenanigans, and it now works in Cloud 9. So, if everyone has a developer.mbed.org account, yeah? You new guys, do y'all have one of those? Developer.mbed.org? Cool. You? So you're going to want to go to developer.mbed.org and sign up for an account. And then once you have an account and you're logged in, so all of you who have an account, go ahead and log in real quick. Then go to this web address. We did an authentication thing so that your embed.org account will authenticate you into Cloud9 services, and it just works. So you don't have to set up another account. That was really spiffy, and I'm very proud of us for being able to do this.
I'm happy to help with any and all account setup issues.
Yeah.
If for some reason they care, which they should, but we're live.
So,
Is this the new way of doing stuff as opposed to the old IDE on embed.org?
there's a whole bunch of really cool stuff that's happening really quickly, and this is what one of our developers was like, we should do this. And management's like, okay, you try that out and see what happens. So the new way, I wouldn't call it a possible new way that has yet to be officially sanctioned, yes.
So if we want to bring in old projects, do we have to import them or do something?
Yeah, and I assume eventually there would be some sort of really cool way to easily bridge it, but because this is essentially a dev project right now, there's not. We're working on the nitty-gritty edge of open betas. anyways, so I'm gonna show you all that. So, developer.mbed.org. You all should all have an account. You should be logged in. When you're logged in, you see this little thing up here in the top right corner. Then I'm gonna go to c9.io/auth/embed. And when I hit that, it's going to take me to a page that looks like this, or similar. I might have logged in already, so I might have a different page. Does y'all's look like this, or at least similar? So I'm going to walk through the process with y'all and create a new workspace. So click on Create New Workspace.
Also, I'm one step behind you, so I'm on mbed.org, and then what?
Go to c9.io/auth/embed.
Okay, now here.
c9.io. We're just using these credentials to log in.
Oh, okay.
io/auth.
What's the Wi-Fi key?
There's a guest one. You see a guest.
That was requiring a message.
Should be the factory, one word under the MBED. Okay, there you go. So now we're going to click on Create New Workspace, and I'm going to make my screen bigger so y'all can see all the way to the back. So that's the URL we're going to. We're going to create a new workspace. And I really hope everyone has the slides at this point because it's about to get a lot of copy pasting.
Where are those slides? I think so. Didn't see the ones for this session. Yeah.
The slides are here.
Is that the number 10?
This is number 11, I want to say. It's because I haven't updated it yet. So you need to go to that link directly. Yeah.
Do you guys encode the read-write permission inside the number, like, does this value 5700 have encoded in it, whether it's read and or writable?
It's not encoded in it, it's just,
Or is it implied?
it's implied keyword, it's actually, let's say, supposed to be read-only. How you implement it is actually up to you, but if you want to buy stuff, you make it read-only. Okay, you got the slides? Everybody has the slides. Cool. Right, so we're going to c9.io/auth/embed. We're going to create a workspace. We're going to import a program. We're going to set the target, and then we're going to hook up to connector to grab some security credentials, and we're going to load a new binary onto the board. It's going to be the end of this process. It's going to take us about 20 minutes with everyone in the room to walk through this, so bear with me here. So we're going to create a new workspace.
I was looking at the slides.
Assuming it'll let me.
Like I was looking at progress.
Right, there we go. Call your workspace whatever you want. I tend to call mine mbed workspace because I'm simple like that. And this is where my mbed projects go. I'm going to make my workspace private because I don't particularly like anyone being able to see my stuff. Not that this matters, but later on it might. So I default to private. You can go public if you like.
With the free accounts, there's a limited amount of privates, right?
Yeah, it's either 3 or 5. So I'm either going to hit this right now as I try and show it to you because Murphy's Law, or I'm going to be just fine. I don't know yet. But you guys should be just fine.
The super stack.
Right. The next thing we're going to click is on this ARM embed thing right here. We're choosing the template. So ARM embed. Cool. And then we're going to clone in a project. This is where I go back to the slides and copy paste. So here, this little link right here expands to like 100-something characters. It points to a GitHub account that's mine with some awesome code on it. So I'm going to click on that. Oh, gimme. Should bring up this page. And I'm going to take the URL from inside the page. And put it right here. Everybody with me? Who's not with me? Not with me?
So where'd you get the get from?
Clicking on this right here.
Is this similar to what, prior to this, we were doing, importing a library in the old UI?
Yeah.
Kind of what we're doing?
All that we're doing at this point is importing example code
Right.
directly from Git repo. That's all. Alternatively, if you knew what you were doing, you could clone this locally and use Yada to build it locally. I'm just showing you Cloud9 because it allows me to assume no one knows how to use Yada in the room, which saves me like 2 hours. So
So, does that mean that I don't need compilers on my laptop? Just,
if you want to do it locally, you can. There's a thing called Yada. It uses GCC or ARMCC or a bunch of others. If you don't want to, you don't have to. Usually, mbed goes the way of make it less complicated, and we file setting up your dev environment under the umbrella of complicated. So if we can make that less complicated, we jump at the opportunity to do so, which is why we're using Cloud9. We're just like, so integrations, and it works, all behind the scenes.
You're not going to support the compiler option tomorrow, right? So do I still have an option in the future to actually run the compiler locally?
You can do that
Or
right
will it
now.
be- Okay.
We had a meetup 2 months ago where I showed everyone how to use Yada and how to build projects, and that is how we would do it. All we're going to be doing is building with Yada in the code here, and it's because half the room doesn't have it installed and I don't have 2 hours to go through it. So-
Can you sort of dwell on that slide? I was just trying to write that URL. I don't have.
So if you go to the slides here,
I don't have a slide. Where does he download to get the slides?
Here, I'll write the links on the
You gotta
board.
pay attention, don't you?
yes you do.
I'll write the links on the board here.
I'm tricky today.
Yes.
Thank you.
And
Make sure you're not
capitalization does matter in these.
Okay.
Let's see here.
Savvy? Savvy. Okay, where'd I go? Great. So we are at the import page. So you've got private clicked, you've selected ARM, and then you added the URL. Everyone's good? We're gonna scroll down to the bottom and hit create workspace. Tap. So you guys should be creating one right now. I just ran out of space.
You ran out.
Sorry about
Murphy's
that.
Law, right.
So I'm going to go back into the previously created one that I happen to know that I have. So
You could just make it public, right?
Sure could, but you
Hmm?
won't.
I said you could just make it public, right? I mean, it's
One of them
it's
is-
on your public GitHub.
my workspace?
Yeah.
Oh yeah.
Not your
it-
workspace, your the code is the report.
Well, I mean the code is public by default, so it doesn't matter. It's more like this workspace can have multiple projects in it. So I may be working on a public project now, but later on I want to work on private projects. So I just assume make the workspace private, and then if I want to share the code, I can share it on GitHub or GitLab or wherever I want to put it. Because I'm paranoid. It's really what it comes down to.
So you don't want people to see you mid-commit.
Yeah.
Yeah.
That's what he really means.
It's really, I don't want them to see my commit messages.
I was gonna say,
before
you don't want to read his commit Yeah, messages.
before you're squashed.
Yeah. Commit messages prior to squash, you don't want to
That's
see
like
that.
you're getting push ready, so
Yeah.
less swear words in the commit log.
I can read it.
Okay.
So the colons are not legible. Very true.
I will make those bold.
Not that it's necessary.
So is everyone's workspace up? It usually takes, a minute to 10, depending on how happy their servers are on a given day. Is your, you in? You're in. Show you're
Throw up
in.
your hand if anyone's running into issues. I'll come.
That has got to be the quickest load I've ever seen from Cloud9. Cool. Usually I have to sit there for like 3 minutes while it creates the workspace. Okay, anyways, it's up.
The new version of Yoda is available.
You can ignore it for the
update
moment.
that, no problem. If you click on that, it'll update it for you.
Right.
Now on the left take. Do we want to?
So this is what you should have. I'm going to make this bigger and also change my colors. No, that's not what I want. Gimme. Okay. Can you all see that better?
Much better.
Sorry about that. I do shenanigans with inverting screen colors and things. Forgot to turn it on. So we are right here at main.cpp. Does everyone have that? Still loading for you? Okay. So we're going to be interested in these three files in the source folder, main, security.h, and simpleclient.h. You can go ahead and open them up. The first one we're going to look at is security.h. So I'm going to bring that to the front. Your security.h should look like this, with nothing in it. Nothing at all. We are now going to go over to another website called Connector, which is the cloud side of this whole shenanigans operation, and grab the security certificate, plug it in here, and load it onto your device. Because this is an because this is currently in open beta preview, this is not necessarily the way you would do it for an end device. There would be automations, there would be better ways to do it than copy pasting it in. So we announced this preview 3 months ago, I think it was, and it's still in beta, so beta. So did your thing load up for you?
Not yet. No.
Darn, Brian, can you give him a hand?
Sure. What's the role of the certificate here?
Security, straight up. There's a public key, private key
Putting
pairing.
it on.
Yes.
We're putting in X509 or so. It's just what's
No,
the key is
it's, I forget what type of certificate it is, but we're going to be putting a certificate on there so it can do public key, private key pairing, among other shenanigans with the server to ensure security.
Is it for TLS or
Yes.
for pairing with
It is.
devices? It's like rec signing requests.
No idea. I am but a lowly apps engineer. I leave it to the
I was
security
just
guys.
curious because it's if this cert's online and like I'm wondering what trust relationship we're setting up.
Talk to me later and I can put you in touch with the person that can
It's like
answer your question.
someone else is gonna like push things into it and make it loud.
Yes, that's
Currently, we have not enabled remote firmware updates.
Gotcha.
When we do, it'll be authenticated to your account, so only you can do it.
That's what I just.
We won't be using shared certificate.
Right. Again, this is back to the open beta part of the conversation.
That's what I was asking. I was just like, am I gonna have my hardware break if I do this?
Okay, so we're going to open up another web page here called Connector. So connector.mbed.com. That's where we're going to go.
Okay.
Come on, give me a new web page. Connector.mbed.com. Yeah, that's fine. This is yet another service that is going to authenticate using your embed developer credentials. So if I'm logged into developer.mbed.org and I hit login up here in the top right, it will just log me in.
After you accept your
Yeah, after you accept the terms every time you log in.
Never asked
just
for
the
the
ones.
credentials. Never asked for the credentials. How come?
I'm sorry, one more time.
This didn't ask for user ID password.
So much like how we authenticated Cloud9 using our developer.mbed.org credentials, this one is also authenticated using the same credentials. So it logged you in using your developer.mbed.org account because see this logo up here on the top left, the ARM embed thing? That means we control it. We also control the online compiler and all that other stuff. So we're like, hey, you just need one login.
So it's baked cookies.
No. It uses...
Yeah, if you hadn't been signed in at the time, it would have redirected you to the embed. Yeah.
So no cookies, slightly more secure and advanced, but effectively yes,
Okay.
cookies, the idea of cookies. But yeah. So everyone on this page with me? Cool. We are now going to generate a security certificate for your device. I didn't accept message. Right here, underneath My Devices, there's a thing that says Security Credentials. That is really small. Can y'all see that? So we should back up one. Yeah, right there. So we click on Security Credentials. I'm going to tell it to give me my credentials. And it pops up this big long thing right here underneath it, which looks like that. You're going to copy paste this into that other thing. This is the one part that will definitely improve in the future. This will not be a copy paste operation forever.
I'm pushing for a copy button.
Yeah, beta, 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 beta.
Where did you get those?
I just generated them. So right now this is Connector, which is the cloud service we're going to be talking to. So I just said, hey, can you give me a series of credentials, please? And he was like, here you go.
From the cloud.
Yeah, put this onto your device and we can talk back and forth.
So beyond security, what does Connector accomplish? Us as opposed to go just straight to the device?
Management and data. So IoT, doing IoT is not hard. Doing it right is incredibly hard. Making sure that your device is secure and that it works and that it can recover from failures and that it will continue to work in a way that is both usable and scalable. Those are the real challenges of IoT. Connector really is just another software service that makes it trivial to manage your devices. We provide REST APIs on one side, and we've got the cloud service and the endpoint stack. And we just say, look, don't worry about it. We'll take care and make sure this works. We guarantee this works. Don't worry about having this work. Worry about what you're doing on either side of it, and it'll just work for you. So that's the proposition: ease of use and guaranteed use. I've tried to do this personally myself over TCP, implementing my own thing, and I've had to hit the reset button at least once every couple days on it. And the whole idea is you shouldn't ever have to touch these devices. It should all be remotely managed, which we enable. So, copy paste this. Come on. Aww. Again, beta, 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 beta.
You do inspect element and like copy the contents of an element.
I could, or I could just highlight it and Control C, which is what I just did. And so now I'm going to go back over here, and I'm going to get rid of all that and paste that in. So in the security.h file, we now have all this cruft.
So,
And I'm going to
we
save
wipe out
it.
everything in security.h, and we just paste it in security.
Control S.
Okay.
Control S?
Yeah, so when you're inside of the Cloud 9 IDE, it works just like a desktop IDE. Your shortcuts still work. In fact, there's this magical button that'll pop me up a terminal, F6. It's pretty cool. So if you want a terminal, there's your terminal. Press F6, it goes away again. So now we've got our security certificates in there. One thing I'm going to point out are these two strings here called embed domain and embed endpoint. These are going to be really useful later. So just check out your embed endpoint name, and that's essentially just a large hash of shenanigans. I'm going to write mine down on the board real quick. So mine, the first little bit is E9C27. So E9C27. That's the beginning stuff. So we've saved it. I'm now going to tell it to compile for my board. So up here in the top right, next to build project, I'm going to click on target, search in registry, and it's the first one on the top left. It says Freedom K64F GCC.
No project selected to build.
Oh, really? So if you're having trouble...
I'm sorry, I clicked on build project, sorry.
Ah, right.
Sorry.
Was
Target.
FRDM-K64F GCC?
Yes. So if I click on search and registry, it should be the first one on the top left. Yes, sir.
Mine says no IoT project selected.
Ah. So you have that. So right click on this. Yep. Set as main project. Yeah. Yep. One pro tip, sometimes C9 drops the ball. If you want to make sure your project is selected to build, you right click on the project name and then click set as main project. It's now going to build that project. So now that I've got my target selected, I've got my project selected, I'm going to hit build.
Well, we went to target name.
And magical shenanigans is going to start happening in the bottom where the server builds my
Oh,
thing
yeah,
for me.
Freedom Day. Okay, I thought we were looking for that.
Cool thing to point out, Cloud9 runs all of these VMs in, well, they're VMs. So this entire IDE is actually sitting inside of a Linux machine in the cloud. So if you look at like the top left of your screen that's getting cut off due to overscanning on mine, you can see the memory, the CPU usage, the disk usage. I think the free one is like 512 meg of RAM and 5 gigabytes of disk space. But if you find these compiles taking a long time and you want to ramp it up to be faster, because they are a service, you can pay them money and they'll be like, yeah, here's 32 gigs of RAM! And your stuff speeds up. So Just pointing that out.
So, can you step back like 30 seconds and?
Yes.
So how do I do the build?
So you have to select what you're building for before you can build something. And so you have to set your target, which is what you're building for. So right here next to build project, there should be a button.
Like target?
Yeah, you can't really see that because it's overscanning. Okay, can you see it now?
Yeah.
It says target. You want it to say Freedom K64F GCC.
Okay.
And then the project you're building, because you imported it, should automatically be selected as your main project. If it wasn't for some reason, you would right click on this and say set as main project. And then you hit build.
Nope, you just answered it.
So I'm building, my terminal right here is building all my stuff up for me. You can see it going through the steps. It's gonna take a little while. The first build, oh no, I broke the server. Try that again. Oh.
At least there's flowers.
Yeah, I know, right?
Yeah.
They're praying for me over my grave.
Good.
Oh, come on, guys.
So it's basically like one, like your VM is the workspace, or, okay.
Yeah. There's a terminal that pops up at the bottom. You can
Yeah, I
actually
was
use to
wondering
manage
about that.
everything.
Okay.
I'm gonna try opening this again and seeing if I can get back in. Cool, I'm back.
Do you have
Yay!
user access on this?
Hmm?
I'm marveling at Cloud9.
It's pretty cool, isn't it?
I was saying, do I get user access?
What the hell is
You do.
I think you can even SSH, but I haven't tried it, I'm not
I never even see any shell.
It's like, I think
So press F6 and you can open up a new terminal to the left there. And it is a full standard bash shell. I even loaded ZSH up in mine, it was
Do you
having
have root
fun.
access?
Within your VM, yes. Yeah.
What is it, Cloud9 built on or something? Yeah, yeah.
Dude, I don't know, I don't work for Cloud9.
You get a full.
It's a virtual ID, that's all I
I know
know.
it was like OpenStack or.
Not a good. Sorry, dude. Questions for them. Anyways, so assuming I can get Murphy's Law to unengage here.
I'm getting really angry.
Yeah, mine's just like waiting for a response.
Yeah, I had to log in to get
Build project.
Like we'll use with
Signed and unsigned signatures. Who wrote this?
Yeah, but like finish people.
It's a joke.
I'm not kidding.
That wasn't a joke.
Finish. Oh. Yeah. Okay. So you guys see it now. It just
I don't know.
zoomed over it.
He knows nothing about it, and then when I poured them up, like, our school surgery.
Thanks for letting me know. I would never
That
found
was-
that in my life.
The way that-
I thought that was like the hash. I was like, sure, like have at it, guys. Connect all you want.
Right, so you hit build, it should give you a thing to download. Who hit build, it finished, and it did not give them something to download?
Not finished.
Not finished? Okay, cool.
200.
Sorry.
You scrolled
Yep.
up.
One benefit of this though is after you do your first compile, every subsequent compile is much faster. So if you want to go mess around with your security.h and change your main file and other stuff, it's much faster than the first time it compiles. This goes back to me saying beta, 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 beta. We haven't, gotten the caching and all the other cool enhancement tricks up and running yet.
Oh, I see, I just logged in again.
So while y'all's stuff is building, I'm going to show you the next steps, just so when it hits, you can run with it. So it should tell you to download a file. If you're in Firefox, if you're in Chrome, it has a weird bug, beta, 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 beta. And so I'll show you where you can download the file from manually. In your source project, you should have a folder called build that has popped up. That build folder is where you're going to find the build files. And under the build files will be nested deep down in there, depending on where you put your source files, the binary. On Firefox, it'll automatically prompt you to download. On Chrome, probably because of security, because someone in Mountain View is super paranoid, it won't allow you to do that.
I think on Chrome there's a pop-up blocker.
Yes.
You can actually disable it for Cloud9, or at least that specific URL. So if you don't want to do the longer build route or the longer download method, you can just disable the pop-up blocker. It shows up in the top right corner of your URL bar.
Yeah. Anyways, so it's going to be under build, source, and then underneath source, you'll find one called mbed client examples.bin when it finishes building. you would right click on it and say download.
So we're just copying this over to the embed device now.
Yep, same way that you used to do it in the old compiler. That's all we're doing. Once you get it over to the embed device, we will then be able to view it in the cloud and even send data back and forth and all kinds of cool shenanigans. So I'm going to show you all how to view the data once we get it on there, and then I'll go into talking about the code and how it's working and all that. So hang on a minute. Yeah, go for it.
I just got an error.
Oh, you got an error. Okay.
I'm sorry, I'm from London. Can you do 30 seconds again, please?
Not
So
a
how do
problem.
I do the, I've got a binary here. So what do I do with that?
Did it finish building?
Yeah,
Okay.
It finished building and it's all downloaded.
Okay.
And
So in that case, I'll show you. So you save your binary.
Right. Well,
So-
it's in my download folder right now.
Yep. So I'm going to open up mine and show you.
Do you mind if I click here?
So where's my downloads? Right. So here's the binary file. I'm sorry that I can't make it bigger, but
Right.
Windows. If you notice, with your board plugged in, you should have a device on your computer called mbed. And so you're going to take that binary and drag and drop it to the board. And can you hand me that board real quick so I can hold it up and show them? Okay. So when I drag and drop it, you're going to see a little light show up on my board that's going to start blinking. So I'm going to let go, and there it goes. That's the board programming. You can see it programming. When that thing goes away and this stops blinking, the board has programmed itself.
Sweet,
So
we just load the binary into
Shenanigans?
the
You're
drive.
putting the file and mine is blinking.
Yeah, but there you go. Mine don't automatically
Wait, you just loaded the binary into the drive?
yeah, there's a bunch of magical shenanigans we've been working on for 10 years. The board programs itself.
It's like the thing of beauty.
It is. So, so now the binary file is on my board. There's a button right next to that light that was going off that says reset. Press that, and your binary is now running on your board. Assuming you have it hooked up to the internet and hooked up to your computer, your board is now talking to mbed connector underneath your account. I'm going to show you how to verify this. For those of you who are curious, there is a serial terminal that you can use.
What's this install Yoda?
I use CoolTerm because it works on Windows and Mac. So I'm going to open it up. I'm going to make sure I connect up to the right one. And I'm going to make sure the speed is set to 11.5200. So, very important. I'm going to connect. Reset on my board, and you should see shenanigans
So
happen.
if I see disk not ejected properly on
That means it worked.
my Mac install, it ejected it's on the board.
Yeah. That's what you should be getting on the serial terminal. It works. It's talking to the server. We are dandy. On Mac, for reference, it doesn't like things unplugging itself. But when it programs itself, it programs it and then power cycles it. And so it forces an eject, so it complains. So if your Mac is complaining, that means it worked.
Is there?
It's kind of like your mom raising you. If she complains, you're doing it right.
Is there an interface on OS 10?
Say again?
Is there an interface for serials on OS 10 or not?
It should show up by default as a USB CDC device.
But how do I do that?
Oh, okay, so you'll want to get CoolTerm.
Okay.
So if you
it's
Google
not-
CoolTerm,
There's no terminal utilities.
Oh, right.
there is, it's called Screen or Minicom or any of the half dozen others, but unless you know what you're doing, you're going to shoot yourself in the foot real quick. So I recommend
What
that you
water
download
connect, you
CoolTerm.
guys?
Hmm?
Is it 96?
11.52.
You guys changed it.
8, 9, and 1.
Good job.
Internal debate.
No, thank you.
I just look at
No.
this.
I welcome the change.
I just see a
Eh,
site, like, go
it breaks a lot of things.
Okay, so how do we get, now that I've got it configured, so then you reset again and we should see this?
Yeah, so if you connect your serial terminal up to it, this is the output that means it's all working correctly. I should probably add a blinky LED or something to it, shouldn't I? Brian, Brian, that's what we should do. We should make the LED go green if it connects and red if it doesn't. We should add that.
Not that hard.
Okay, we will do that for the next revision of the code tomorrow morning. Anyway, so this tells me that my stuff is up. For y'all, don't worry about connecting the serial terminal. You can do it if you like, but as long as you're plugged into Ethernet, you're plugged in the same area that I am, hit the reset button, your code should be running, you should be absolutely fine. So I'm going to show you how to validate this now. So if I go back to connector, where we got the security.h file, and I go over to the left-hand side. No, I don't want Firebug. And I go over to the left-hand side. There's this area called API console. API console, if you click on it, brings up something that looks like this. Can you all see that better now? Cool. API console, I click on the end of endpoints. And remember how I told you mine was E9C27? Well, sure enough, there's my endpoint. I can click on it, and here's all the stuff that it has. So you can go down various levels into this and check out the data on those various levels. So I'm going to show you something cool. If I just say endpoints at the top level and say test API, it comes back and says, yeah, cool, you've got 2 endpoints registered, because I've got one here and one at the office that I'm doing regression testing on. So I've got 2 endpoints, y'all should only have 1. It tells me the name and the type of the endpoint and the status of the endpoint. If the endpoint were to disconnect or its internet connection were to go faulty, it would switch its status from active to something else. Remember how I told you earlier that aside from the resource or object ID, object instance resource ID, there was also metadata tags that we could use to do further pigeonholing of our data? This type string is one of those. You can change the type of your endpoint to be anything you want. And it's just a string. So I'll show you how to do that in the code here in just a second. If I go and I add further slash endpoint name, so E9C27, this is mine, and I say test API again, I'm now going further down into the data. Instead of saying at the domain level, what are the endpoints I have, I'm now saying, hey domain, tell me about that endpoint by its name. So that endpoint returns a series of JSON data telling me all the object ID, object instance resource IDs that it has. So I've got one on here that's test/0/s. I'm going to tell you right now that s is a static resource. Then I've got one that's test/0/d. Notice I'm not using the number schema. I'm totally abusing the protocol here. I'm just pointing out you can do this. You can make it human legible. But if my web app was to use this and then I said, hey, I'm going to let your web app use my stuff, unless I told you explicitly that test/0/s was a static resource, you'd have no idea what it was. So this is bad form, but just for the purposes of illustrating it. And then there's a device object, /3/0/2, 301, 317. So if you remember, 301 is going to be the model ID number. Further down, 300, that's going to be the manufacturer ID string, things like that. So let's try looking at 3000. 300. So that should be device object ID, object instance 0, resource ID 0, which is the manufacturer string. So if I go /3/0/0 test, it's now creating my device. It comes back with this string right here. It actually comes back with all this data above it, but after the server does the security hashes and all the shenanigans that takes the security and translates it back to human readable data and machine readable data, it's a string called manufacturer string, which I put in the code we'll be modifying shortly. So you could change the string if you wanted to. Now the really cool stuff that you're actually here for, I'm going to show you how to read the dynamic resource that I made. So now I'm going to check out my test resource, or my dynamic test object. So test/0/d, hit test API. Decoded payload value is 0. Now, we did a cool thing with this code. We rigged up software switch number 2 to increment that number. So make sure you don't hit 3. 3 will unregister your device. Hit 2. 2 will increment, 3 will unregister. 2 very different things. So 2 is the one right next to the FRDM gold stuff. So if I press that, so I pressed it once. Now I'm going to go back over here and say, hey, check it again. it's now incremented to 1. I'm now going to press it a couple different times. And if I test my API again, sure enough, I've pressed the button 11 times.
Austin, can you go back over which, after the URL up there, how are we on
Right.
that, where you are? Yeah, that.
So if the base URL it gives you is
Right.
addressing every endpoint in your domain.
Right, and you select your endpoint.
Right, so you select your endpoint. So mine was E9, C2, whatever. You should only have one thing. So you just select that. And then I'm telling it, I want to look at /test/0/D. So test/0/D.
Okay, there.
And
Alright.
you'll see where that comes from as soon as we start looking at the code.
So then we want to, responsible come only from cache?
No, don't put anything else in
No.
there.
It's trying to auto-complete.
It is, but if you click away from it, it won't autocomplete.
504.
504, ooh,
Yeah, right?
202. Okay, there we go.
Gateway time up?
yeah, try hitting test API
I'll come over
again.
to you just a bit, well, we can take a look.
Anyway, so that is how we could read something.
Oh, yeah.
By the way, that dynamic resource, because it is read-writable on my device, I could then change that from my web app to be something else if I wanted to. But that's the next meetup. So next time, we'll figure out how to write a web app that changes data on the device. Right now, we're just reading the data. Because the code you write. So now we're going to go into that code that I had you wrote, and I'll walk you through what everything does. Cool. So we've completed this slide 30 minutes later. Funny enough, that was not the hardest part. Now I'm going to show you what the code is and how it works and how we got all those resource identifiers and object IDs and where everything came from. Cool?
I think I'm good at 504 right now.
I'll come over there now.
He's trying to break your thing.
It's alright. If you break it, that means we fix it and it gets
Try
stronger.
that guy. Yeah, that's that reset button actually.
Use the URL.
You're in my queue. Did you find yours?
Yeah, I think I
Cool. Great. Next. I believe it was you, sir.
Yeah,
That's just the best way to get it.
Sure. Do you have it running?
Yeah.
So you just download it and you just drag and drop it onto there?
Yeah, that's
Yeah,
We'll leave
here
it,
it
we'll
goes.
leave
So,
it
yeah,
as
there's
that.
that.
Yeah.
And I mean, if you delete them, I don't
Whatever it is. We think it's gonna be too
Yeah, which one just take mine?
Bail on.
Sweet. So yeah, then you hit reset on that somewhere.
So once mine are done, then I should keep getting it.
Yes. Okay. So just make sure you're on 115.2.1.1 and it's on the right count port.
It's probably the only one that's on.
You have to make sure it's not. Try to you can flash it, so it's like something. Yeah, I mean, it's definitely connected. Let's see. What was that cool term? Just try it. Do you know what version of OS X you're running on? I'm not sure what the.
Right here for source, planning project name.
Oh, here we go.
Now we're awesome.
So then,
Out of curiosity, is it communicating over HTTP or HTTP?
Yeah, it's under build.
Well, at least you get the connection.
this guy should. Well, no, so once you flash it.
Okay. What time are we at? Hey. Okay. Can't get Charles' attention again. bringing it back up here. We've got about 40 minutes. I'm going to try and go through as much of the code as I can in that remaining time. Is that cool? Do y'all want to go through the code and see how all this works? Yeah? Yeah? Okay.
Yuka's 504.
We're not 504 anymore.
Never mind, hooray.
Awesome. Okay, so some quick tips about Cloud9. You can hit the F6 key and it'll bring up your terminal, which allows you to do all kinds of the crazy Linux shenanigans you're used to being able to do. You can explore the file directories. It's actually hiding some build files from you called Yada modules. So you can either enable that in your preferences or view it on the command line. Yeah. Yeah. Oh, other cool tip, pro tip. If you want to open a file, you can either navigate it to it on the left-hand side or in the terminal you run an ls command. If you click on the file name, it'll automatically open it for you because Cloud9 did some crazy, awesome integrations. Okay, so now for the code. Y'all good? So, remember how I said, remember how when we went through the objects, there were two types of objects? There were the OMA official ones and the non-official ones. Based along those lines, we created two types of things. We created one which is a interface factory, which is really just a handy way to generate the code for you, but we only did it for the official spec things, so 0 through 16. They've got official, easy-to-use code generators. Everything else you have to do on your own. So we're going to walk through 3 examples. One example is how to use the official stuff. One is how to generate your own custom stuff. And then there's going to be another one for showing you how to do a custom dynamic or custom static. Sound good? Cool. I'm going to emphasize one more time the object ID, object instance, resource ID thing. Those 3 things are really important again because each one is a different function call. So like when you want to create your own custom thing, you have to first create the object ID, then create the resource ID, or then create the object instance, then create the resource ID. And so you create those 3 things, adding and building up this object. Cool? Okay, let's get into it. Would y'all prefer this color or this color?
Black.
Black? That way? Yeah. Okay, so this is how you would create a instance pairing using the interface library. So this is how to create the device. So right here, we're calling the Intuit interface factory, and then we're calling the subfunction create device. This is going to create a object ID and a object instance pairing. So this function call right here will create /3/0. We still have to assign resource IDs to that, but it's a one-line thing to create those 2 things. It's just a little shortcut, that's all it is. Then this code right here adds 4 resources to this. It adds manufacturer, type, model number, and serial number. Notice how nowhere in here does it mention anything about /0/1/2/3. It's just part of, it's an enumeration. It's like, hey, don't worry about it. We kind of made it in plain English so you can understand and create these. So this creates this. It's a lot smaller than I thought it would be. Can everyone read that? Or does everyone at least have the slides? So this code right here creates /3/0. It's used all the way in here. And then these 4 lines create 4 resource IDs. The 3rd one just got cropped off the bottom. My apologies. Presentation notes. So manufacturer ID, which is right here. Model number, which is the red, which is right here. And serial number, which is the green, is right here. Type should also be there. So just imagine it's there for me. Each of them has a resource ID that is assigned in that giant XML document. And because it is official spec, this generator was like, oh yeah, I know that's 0, don't worry about it, I got it for you. So you're good. So at this point you have an endpoint with, again, 4 resources on it. Or, well, you have an endpoint with a device object, and that device object has one instance of the object with 4 resources on that instance. Savvy?
So I want to understand what part of that function call specifically generates the 3/0 with the URL.
So this device object right here is just a magical data structure that represents that in whatever the stack is doing. This factory is just that, it's a factory. It creates the /3/0 equivalent data structure representation. In a second, you'll see why this is so convenient, because this is one line. We're about to have to turn it into 6 lines. So on the next slide, this is an example of a custom static resource. Oh man, it lost the color. Not cool. So in this case, each level of that 3 levels is broken up into its own line. So on this first line, we're creating the object ID. On the second line, we create the object instance. And then down here, we actually create the resource to assign to it. So this is /test, this is /0, and this is /s. So we create the object ID, the object instance, and the resource ID all separately. And the way that they get paired together is because the object ID here, test, is in the underscore object variable. Then we add to the underscore object variable an instance. Okay. And then, let me see, that then returns an instance variable. And then here, this instance variable, we add a resource to that.
Okay.
Yeah, not the most user-friendly thing, is it?
Oh, it's great. Yeah, it's great, yeah, what he said.
Cool.
So,
It's good. It's the way to do it.
Yeah.
I defer to your experience, I wouldn't know. So by default, I guess, if you don't put any arguments in for the create object instance call, does it just auto increment, or is there another way?
So if I were to want to create another instance, what I would then say is here, I'd say instance, object, create object instance, it would return something else. So I would say, instance 2 equals this. Instance 2 would then be /1. You can, inside of this, specify the instance number. If you don't, it automatically defaults to the last highest number incremented +1.
Okay, great.
Yeah.
So the object ID there is text. Can you do text with instance numbers or?
So I used strings here,
Right.
which, by the way, value string.
Okay.
But this string doesn't mean that string. This string means this thing right here, which is that is a string. I just happened to use a string instead of a number because I wanted to make it easier to find in the API console.
Okay.
That was the only reason. I am totally breaking spec, and this is not how you should do it. I just did it so it'd be easier to see what I'm talking about.
That makes sense. Okay.
Yeah. So this should have been like some number, like 3303. Yeah, because this is a test. If I was a temperature, it'd be 3303, and then instead of /s, it'd be 5700.
Okay.
That's what I should have done. But again, to make it easier to tell which one's static, which one's dynamic, and all that stuff. Also going to point out right here, this static resource test string. This is the metadata resource type that is applied here. So if you go and you look in the API console and you say, tell me what is /test/0/s, this string is going to show up in there as its type. You want me to show you that?
Yeah, I could try.
Okay, let me show you that. So if I go back over to my API console and I do /test/0/s, assuming I use the same code that I put on the slides, which I think I did, there you go, right there. Is that right?
Close enough.
Yeah, let me double check that real quick. The code that I used in here, F6. Static resource test, static value. Where did I declare static value? I declared static value up here.
You can't control it, can you?
Right, sorry, so that is incorrect. It's instead of hello world in my code, I use that. So that's what it's reporting on the API console, but the type should also be there. See, where's type? Oh. I think I have to go back one more. Well, Well, darn. So right here, this type bit is supposed to get filled out with that thing. It didn't because apparently the slide code doesn't match my actual code that I implemented. Sorry about that.
I've done it.
Okay, so is everyone with me here on how we created a static resource?
It happens all the time.
I'm gonna point out.
Do a quick highlight of how that populates again real quick.
Yeah, so object ID, object instance, resource ID. When we create the resource, because it is a static resource, we assign the value at that time. If it's a dynamic resource, we say, oh, you take the value of some other thing that's over there with a pointer or something, because it can change.
So it doesn't have.
Whereas here, we just assign it. So I'm saying the value when you query this slash test slash 0 slash s, you're going to get this thing back. The static value right here is static value.
It's actually, it's
How does it know that it's associated with tests? When you run that lower line there, how does it know that it's associated
So
with tests?
when you run the object instantiator, it gives me an object ID.
I see.
It's held inside this variable called object. And then object is used right here to create an instance in that object. And that instance is given a pointer here, an instance. And then underneath that instance is creating a resource. I could chain it all together, but it gets really small when you put it together on a slide, one thing after another.
I know that makes sense.
Yeah. Also, thing about this stack, everything's a class. So when you go to create your own example code, you're going to create a class that uses this stack. And it'll keep track of these return variables and things like that.
So your instance doesn't mean the actual device, right?
No.
So if I have multiple of these, like if I want to see one device.
So that's called an endpoint. So remember there's endpoint, and then inside of an endpoint you have an object ID, object instance, resource ID. There's another thing when I first start up the code that says, oh, give me an endpoint class. And actually, this thing is part of that endpoint class. It's just not here on this example slide. In the code, I can show you where it is here in about 5 minutes. So this is how you create a static value. Oh, hey, I had nice handy arrows. If you want to do other types of static values besides strings, there's also integers, floats, booleans, opaque, time, and object links. I'm not entirely sure what opaque and object links are, but they're a thing in the spec, so it's totally doable in the INU. This is probably what you're actually most interested in. This is how to create a dynamic object. So this has something that can change. I can change the value of this from the server, or I can change it locally and then report up the changes to the server. This is where all the really good meat, the really good stuff is. We'll walk you through it again. You create the test object, assuming I hadn't already created it. In the actual code, I used the same one from the previous slide, but just to make it clear, separate from the previous slide. I create the object instance, or no, create the object ID right here using the interface factory to create an object called test. So now it's /test. I then create an instance, an object instance under the test object ID. So it's test/0, and then here I create a dynamic resource. So /test/0/d.
I thought it was supposed to be an integer.
Hmm?
I thought it was supposed to be like an integer. Wait.
The name has nothing to do with the value that it's associated with.
Alright, let's see.
Oh, you're saying the name is supposed to be an integer?
Yeah.
By spec, yes. Sorry, I mentioned about 10 minutes ago, I totally broke spec with this example to make it easier to understand. Also, in case you hadn't caught on, the D is for dynamic, the S in the previous one was for static.
So do as I say, not as I do.
Yes,
Got it.
very much so. And this was so you could find the static and the dynamic variable, or the it's so you could find them in the tons of other cruft of the /3/ whatever. I just wanted to make it really obvious what you're supposed to be looking at.
So in the backend, it's all stored as strings then?
It's stored as a bunch of stuff. Strings are part of it, yeah. The data that you're associating with this, in this case, we're saying it's going to be an integer value, which is why when I pushed the button, it said 0, and then 1, and then 2. I could just as easily have said I'm associating a string with you and pushed back TWO, ONE, THRE, whatever I wanted to. It doesn't matter what type of data you send back. And in fact, I could send back an integer representation of the ASCII characters if I wanted. This resource type is primarily so that the server, who knows hopefully nothing about your object other than the metadata it's getting back, can try and classify it in its algorithm and go, oh, okay, if he's handing me back a string, that's its name. If he's handing me back an integer, that's its value. Cool, done, end of day. So you can write algorithms to interpret this data however you like. We just provide as many options as possible so you can make your stuff work. One thing to notice here is we're not done. Once we created the resource, that's not the end of the code. If you notice, this only has 3 lines, or no, 4 lines to it, whereas the previous one had 5 lines. It's because when you do a static resource, at the time of the resource creation, you also assign it a value. It's not the case with a dynamic resource. When you create a dynamic resource, we still haven't given it a value yet. We've just said, hey, you're gonna be dynamic, your stuff can change, you're gonna hold an integer, cool, chill out for a second until I get you something. Down here is where we actually give it its value. And so what I do is I create a buffer, I then say, hey, by the way, I'm going to, this dynamic resource, you're going to use this buffer as your value. So when someone asks you for stuff, get it from here. So that's all that this line right here is doing, is saying, this is where your data lives. When you want to read your data value, get it from here. When you write to it, put it here. This is where it is. This is how big it is. That's the end of the story. Should click through the arrows because I took time to animate it. There's one last line at the bottom that I haven't talked about yet. This is the line that controls how your web app can access this data field. In the case of a static resource, it's by default readable, unless you say, no, don't set it readable. In the case of a dynamic resource, you have to specify what you want, what data operations you want allowed on that thing. So remember how I said I can do get, put, post, and delete? Right here I'm saying get and put are allowed. So the server can get this value, and it can change this value, but it cannot delete it, and it cannot post to it. I'm only allowing 2 operations, get and put.
Does the order of that nomenclature matter?
Yes, that's just an enum. If you go and you look down in the code, there's like get allowed, get put allowed, get put post delete allowed. There's every enumeration of those things there.
But I don't think there's a put get. So, yeah.
Yeah, so it'd be get put,
Yeah.
not put get. Okay. Everyone follow? Yes, sir.
Isn't this buffer a local variable on the stack?
This is a
Which will,
local thing on the embedded device. So this is taken kind of out of context. This is actually part of a bigger class. There's actually 2 or 3 lines here that I deleted to make it easier to understand what I was doing. Those lines took that buffer and assigned it to a private variable so that its state was preserved between uses and all that. But yeah, but you get the idea of you have to you create the resource and then you assign it its value. That was awesome. There's one other thing you need to know how to do. That's how to update that dynamic resource. Because I've showed you how to create it. I haven't told you how to change its value. That's what this code does. So first things first, we have to now go grab that resource and then change its value. And so the only thing that this code right here does, remember how earlier I said when you create your object instance, you want to save it somewhere so you can reference it later? That's what it does. It takes the object instance that we saved somewhere, checks to make sure it's a valid thing. If it's invalid, it'd be null, by the way. So a simple if statement is the easiest way to catch it. So it goes, hey, is that a real object? Cool, okay, grab an instance from it. Did that instance actually exist? Okay, cool. Then grab the resource D, which I specify right here. And there really should be another check right here that says, hey, did I grab the resource? Cool, it's actually a valid resource. Okay, now process the data. But that was getting really long, so I just kind of scooped it up. You cannot use if statements to check your stuff. It's totally valid code, it'll work. Bad form, it'll crash into eventually. So I recommend always checking the return from the stack to make sure things work and have error handling. Right here is the nitty gritty bit. We now have in resource a pointer to the D resource. We grab the buffer, we put some new stuff in the buffer, and then we set the value to the contents of that buffer again.
So that's the same buffer?
Yeah. All I did at this point, this buffer is just assume it was saved from earlier, so I didn't just redeclare it. Ignore the char.
Okay.
Just assume it exists still previously.
Gotcha.
I'm just saying, there's a buffer thing you gotta mess with. Then you change the contents and set.
And underscore value is cutting, it's on the top of this object somewhere, I guess, right? I don't see it passed in.
Yeah, underscore value is right here in this magical deleted space that I removed.
Yeah. But yeah, that's what was passed in, that we're assigning to the.
Yeah, and it's just the number of button presses, and all that's happening is, underscore value is an integer that's like 4 or 5 or whatever.
Yeah.
This sprintf converts it, fills up the buffer, and then updates the resource to be like, hey, new buffer value, there you go. SharpEye, by the way. These are all of the ways to handle stuff. So remember how I just said you could have get, put, post, and delete on the endpoint itself? There's one function, it's called value updated, and it has this prototype. This is the entry point for the stack for all get and post and delete, get, put, post, and delete calls made to the device. So no matter if I'm calling resource D, resource E, resource whatever, if I try and do a get, put, post, or delete to it, this one function will handle all of them. It is the single callback for, hey, someone's trying to touch me or read me or something, here, you handle it. And this is the function that takes care of it. The way that you figure out, one, who is talking to you, and two, what they're trying to get, is you use these functions on the left, which fall off the bottom of the page. Great. You can check the resource, the object instance, the object ID. You can check the type, the name, the descriptor. You can check if it's observable. You can check any kind of data about the thing they're trying to get, and then you can use that data to decide how to respond to the request. So what I would do is I'd say, because of this simple instance and I only have test/0/d that I care about, I'd say, hey, is the object ID test? Cool. Is the resource ID D? Cool. Okay, they're just asking for the value. Sure, give them the value, and that's that. You pass in two things to it, the base and the base type. Type tells you if it's object resource, object instance, and the base tells you what you can do to it. This is going to be a really handy table of reference here when we start looking at the source code here a little bit further on. Did I already pass it? Yeah, I already passed it. Cool. Questions, thoughts, concerns, existential crises, things I did terribly, please tell me now.
So you said you were going to talk about the throttling thing?
Right. So do you want the honest answer or the politically correct answer?
The honest answer.
The honest answer is the company who put all this stuff together, and there's a lot of stuff that's gone into this. They put up Connector for free. And so if you look at it, you get 100 devices and 2 API keys. And what was the throttle? Was it 1,000 messages? Something like that?
10,000 an hour.
10,000 messages an hour for everything in your domain is what you're allowed.
Yeah.
Yeah. So that's what you're limited to. Because Connector is a free service, it's a dev environment, it's meant for you to play with, and meant for you to get your stuff prototyped and working. And then when you want to go to production, there will be plugins for everything, but of course then there's money and marketing guys get involved, and that's above my head. So that's roughly what it is. Do we remember what the rate limit was? Because we hit that earlier. Not the 10,000, but roughly how fast we could send stuff between messages.
I'm not sure if there is, besides maybe a second. It might be a second, but
It's roughly a second, but keep in mind these IoT devices are designed to be low power, infrequent users. So if you're doing really heavy hitting stuff, maybe you don't want to be doing it as IoT. Maybe you want a direct linkage. Like I certainly wouldn't do motor control through this. Nothing real time. None of this is real time in the slightest.
or
I-
Yeah,
series- time
sensor
series
data,
data.
yeah, sensor. Here's the data.
Yeah, pseudo real-time stuff is the whole purpose of all of this. If it's real-time or safety critical, this is not your solution, not the bag of tricks you want.
So are any of the payment schemes figured out at this point?
Dude, not the guy to ask. If you want, talk to me later. I can point you in the right direction. All I know is there's eventually a plan to make money off something over there. My entire purpose is to help you all build awesome.
So is it possible to replace like your thing with some other service? Is that with portable?
So we do use open standards. Co-op is an open standard. Lightweight MDM is an open standard. if you wanted to, you could certainly replicate it. It would take you a couple hundred engineers and a couple of years worth of work to do it. So I think the value proposition we have is, it works! Look, you don't have to spend millions of dollars in research. It just works. Use it, go. So, it's a service. I'm gonna use the free version though, because nothing I do needs more than that.
Cool.
And I believe at this point, I've got a couple of challenges for you guys in the 15 minutes we have left. If any of y'all would like to try it, try messing with your code and changing static and dynamic resources around. Try changing the type. Try creating an LED object and turning it on and off. Try reporting its status up. I'd recommend trying to have the button turn the LED on and off, and then report it up to connectors so you can get the console.
Some sort of.
Try changing the integer type to Boolean, say. Play Stump the Engineer, ask me hard questions, and I'm happy to answer them.
And also go over the main.cpp, just walk through the code a little bit if you don't mind.
Yeah, sure, I can do that. So in the main
That's what we were changing, right?
Actually, no. So there's three files. Three files we got here. There's the main.cpp that is the instantiation of everything. There's the security.h that has your security certificates, endpoint name, and domain name. And then there's the simple client.h, which is an example class that I created for you, so that you can take it, copy, paste it, and do what you like. So in the main, if you look at it, right,
Let's go back to the simple podcast.
But
That's what we're gonna be on.
I'm going to show you the main and then show you how it works. So over here in the main, you create an interface right here, which is just creating the endpoint object to register with the server. Then right here, you create a bunch of objects. These are functions that in that simple client.h actually make all those calls that you just saw in the previous slides. And so I just wrap them inside of a class so that from the main function, it's one function call instead of 6. That's the whole point of the class, is to make it easier for your main.cpp to use. Then we put together a list of all the objects we just created. And right here, we register them with MDS. So when we register them, we say, hey, MDS, here's the list of everything I got. I'll be chilling here until you need me. Cool, peace out. And then this stuff right here issues the registration code. None of this has anything to do with the previous slides, except that this uses the previous slides. So now I'm going to show you simple client.h, which is where all that code was. This is where all the good stuff lives. Mbed has this philosophy of keeping it simple and making it easier. I would not expect you in a million years to be able to write this simple client.h on your own. Well, I'd expect him to, because I know he can do it. But I wouldn't expect any web dev to ever be able to write simple client.h on their own. I would expect them to be able to take the one I've written and heavily commented and go, oh, so that's how you create a dynamic resource. Copy, paste, change the name, change the buffer it's pointing at, and then in their main code, update that buffer periodically. That's what I expect them to do.
I'm not sure what.
So that's all you should ever have to do, is modify the class and then use it.
That's what he is.
That's what I use too.
Yep, exactly. There will eventually be a much simpler template, but I had about a week and a half to throw this together, so my apologies for the lack of polish. First things first, this create generic object. This function is where we actually create the static and dynamic objects, the test/0/d and the test/0/s. This is where that's done. And you can see all the code from the slides that was copy pasted and how I kind of cut it up and slammed it together.
It's in there somewhere.
It's, yeah, so here's the creation of the static resource, S. Here's the creation of the dynamic resource and the setting of its buffer, right there. And then right here up above it is where I create object instance, object ID. So it's, test/0, and then /d, and then /s. Also, if you notice this underscore object right here, that is not created right here. It is a private variable. So if I scroll all the way down to the bottom, there it is. So it's a private variable in the class that I can then come back and access later. You could also save the instances of resources, so you wouldn't have to recreate the whole ladder every time. We just like to recreate the ladder to show you how to do it. Back
So
up
you're,
top.
so you're storing the value for the button increment, you're storing the value in that, and then the buffer is just meant for writing it.
Yeah, I could just as easily, instead of saying string type and then sprintfing it to the buffer,
Yeah.
I could have just been like, value,
Okay.
and called it integer, but I wanted to,
Okay.
you know, lead you along the educational path, not necessarily by the most efficient means necessary. And then this bit right here, the update resource, is the function that we use to update the dynamic resource. So you can see how when it is called, it takes the object that we saved, finds the instance, finds the resource, and updates its value. Yeah.
So in security.h, do we have to use the same embed endpoint names, or can we, like, if I have multiple of these devices, can I have?
So right now, when you created the security.h file on the server, you hit generate. It generated the embed domain. That'll be the same across all your endpoints. So whenever you hit generate, the embed domain will always be the same.
Yeah.
But then it will automatically assign you a new UUID hash endpoint name. There's no reason we shouldn't enable it so you can change it. But for the security to work, the endpoint name has to match the device and the server. Right now, there's no publicly accessible way to change the endpoint name of the server. I imagine in the non-beta, beta revs, that'll be a thing. So they'll be like, oh, well, instead of a hash, let's call it Joe's thing. And it could easily be changed. Just beta. Right now, though, I can tell you, if you try and you change the endpoint name, you'll change it on the device here by changing it to security.h. It won't change on the server. That'll cause a security fault, and it'll be like, nope. And that's that. So I tried doing this earlier because we used to not require security on the pre-release versions. That's where we're able to do stuff like that and call it like Austin's awesome endpoint and things. But now the public-facing connector is entirely secured. That's our entire story, locked down tight. You don't have to worry about it. It just works. So you can't. Any other questions? Yeah.
Do you have any documentation on memory management?
Hmm?
Do you have any documentation on memory management for embed? I'm noticing like strings and pointers coming back, but where is the memory coming from?
So I can point you, that's actually a really good question. I can point you to docs.mbed.com.
So when, like, for example, when I get null back, I'm assuming that my embedded target has no more memory, or I'm doing something wrong.
So
Take a look at what you're talking about if you wanna.
Yeah, so when you're getting.
go to docs.mbed.com. I'm just going to point everyone in the room at this and the guys on the internet. Docs.mbed.com. There's this thing right here called Embed Client Guide. This is what you want to read to find out everything you want to know about Embed Client. It has pointers to all the right places. It has all the error return codes and all that shenanigans. So if you see something happening that looks weird, where you're like, why that? Go check this out. There's a ton of docs here to read through, and it's totally searchable. The null, I don't know.
We'll take a look at it, yeah.
I've been working with it for like 3 weeks. There's
So
still stuff I don't fully understand myself. Can I show you one other thing in the code though? So if we keep going down in simpleclient.h, you're going to hit this little magical barrier. Everything above the barrier, I totally expect you to be able to understand and change. Everything below the barrier, don't worry about it. Don't worry, just copy paste, it's all good. If you really want to understand how things work in the nitty gritty, go through and read it. I made sure to comment it heavily for you. I understood all of this only 3 days ago, so I went through the same process you're going through, and I made sure to comment everything that popped into my head. So hopefully you'll be tired of hearing my voice in your head by the time it's all said and done. And that.
How do you change the target? How do you change the target?
Oh, you mean what you're compiling for?
Yeah.
Right, so if I were to go up here and click on target,
Okay.
click search registry, you're wanting to compile for that board, right? So here's another fun fact. Embed Client currently works on a small number of boards. The K64F is one of the better ones because it has an Ethernet jack and a ton of memory, and so it's like, yay, it all works before optimization. So that's why I have this out here. It also works natively on Linux. So if any of you are running Linux today, instead of compiling for K64F, you could just as easily compile for x86 native Linux or Linux native, and it would run. What I'm going to tell you is this is a little bit deceiving because it is architecture specific based on the VM it is currently running on. So if I compile this here, it will run in Cloud 9. But Cloud 9 is probably running on an x86 server with some sort of virtualization layer. So it'll work there. If I put that on a Raspberry Pi, which is an ARM chip, totally different instruction set, totally different architecture, it wouldn't run. However, if I went to the Linux that runs on Raspberry Pi, downloaded Yada, and compiled it there on the Pi, it would work. And in fact, I've done that, and I have a Pi sitting on my desk that is running Embed Client Stack because I installed Python, using pip installed Yada, cloned the project, used Yada to build the project for Linux native as the target. I was like, oh, your GCC is set up for your environment, because of course it is, because Linux builds most of its stuff from source anyways. So all the settings are already there. And so it's just like system settings, go. So if you wanted to build it for your board, you need to install Python on the board, you need to install Yada on the board, you need to clone the project to your board and then build it on the board. Or figure out what those settings are and build it somewhere else for the board, but it's honestly easier to build it on the board because everything always works, whereas there are very few neckbeards in the world who can build it somewhere else for something else and always have it work.
So one question, you said that you can also build on the Linux machine, right?
Yeah.
So that is not an RTOS, and Mbed OS is it? Because we are targeting Mbed OS, right? So can Mbed OS run on, like how is that?
So there's a separate Linux example for client that actually uses like POSIX libraries and like.
That's completely different one.
So the client libraries
There's this wonderful tool called Yada that we're using behind the scenes here. Yada is a package manager / source builder / wizard of things. And this actually goes to a much deeper question of why are embedded systems so hard to build stuff for? And it's because the architecture and settings on a chip-to-chip basis vary as widely as an x86 and a PowerPC architecture do. And so it's been very hard for a very long time to run one set of software on multiple chips, because it's the same thing as trying to run one set of software on an x86 or an ARM or a PowerPC or whatever the heck was back in the day. We created Yada because Embed's goal is to write software for all these different chips and just have it work. And part of a byproduct of that was it also working for all of the Cortex-A chips, which also have been ported for Linux. We didn't actually expect it to work. We were like, huh, I wonder, oh my God, it works. So it kind of surprised us, and it's a kind of not on purpose byproduct of the build system we used. Did that answer your question at all?
A little bit, I still have a doubt. If that is a
So before everyone goes, because we got 5 minutes, if I could ask you to return the boards, because if you notice I used to have 2 boxes, now I've got 1 box, shenanigans. I have to return all these and check them in. If you need parking vouchers, we have them. It covers up to like $20, so that should be roughly 2.5 hours. If you have any questions about things, I will be here until you have no more questions, although we might have to answer them out there because she wants us out if you're at 9. Clean up. If anyone wants to help me wrap up Ethernet cables, I'd very much appreciate it, and just drop them up here in the box along with the USB cables. Oh, one other thing. Because it's the end of the year, which is also the end of our fiscal year, I have buttons. So if you would like buttons, please come take as many buttons as you like. People on the internet, I'm sorry, it's a perk of being here in person. So come get a button, brag to all your friends, be a ninja. Yeah. Have several buttons. I don't want the buttons, they have to go.